Okay, let's look at how to start running a simulation with experimental profile. So most likely the experimental is gonna give you PNG file. P stands for profile, G stands for geometry. Profile file give you density, temperature, and rotation velocity, stuff in that manner. Geometry is more of a magnetic geometry and the real space mapping from real space mapping. So since sometimes they are not in the format that we desire, IFS script has provided one of a script that reading the GMP file and output a file called iterdb. So the way to run it is go to this run Python, go into the directory that contains your IFS script and type make iterdb, and then the name of your G file, the name of your P file, and enter. There is all the data that you see if it makes sense. Prime is pretty much the derivative of the quantity. Eta is, I think, is length scale of density over length scale of temperature. I think, or reverse. So sometimes it will give you warning. You see the measurement from the Vtor calculated from ER or Vtor is different, and you select which one you want. Say we want from the ER, which is this one, and close this one and see we want from ER number 1, and done. Now you have the default name. You can change the default name in the make iterdb, but I'm just too lazy to change it. I can change it here. So now you have your profile, P file, G file, and iterdb file. So now you open the parameters. I have everything set up. If you're not sure if you can parallel the correct way, you just put -1. The computer will automatically choose whichever parallelization you want. So for us, we only need to worry too much. Most of the time, we worry about x0, the location, and the common grid. As I remembered, are like such for local linear. And it can do a scan list on whichever variables that you want to do. Say I did a scan list on ky. And you can also change kx as well. This is most commonly changed. Most of the time you're required to do like sometime a k-scan. They need to change ky and kx. Sometimes into the location scan, you need to go through a scan through x0. And that's the output directory that you want such things to be output at. And there's name of iterdb file. And that's the initial condition. If you want something magnetic, you can change to ALMMT. And you can also change the hyperdiffusivity. We'll talk more later on. Basically, once you see something, you have numerical issues, you want to damp out something fine, some fine structured mode, you can increase the hyperdiffusivity to damp it out. But it's a fine line to actually damp out the mode that you actually want. Here, since we're running through the experimental data, you want the tracer EFIT, the type of your magnetic geometry, and put the magnetic geometry file name here. And everything should be -1. And if you want to look at something near the outboard meet plane, or meet plane, or something, you want the simulation has more dense distribution of grid around the meet plane, then you can change the edge op to like higher number. So now the species, and then you can either turn on or off the E cross B. And in order to turn off, you can just comment it off, comment those line off, like such. And here the same, you need the directory of your output. Everything is -1. And the profile -2 is pretty much you wanted to read from the experimental data, from the profile that you provided. So here, this case is 3 species. So everything here is what you need for running 3 species simulation. For 2 species, it will have a little bit different. So, for instance, for us, we're wanting to have electron as a non-adiabatic species. So you can do 1 species run because it's faster, and sometimes it will give you the result. Actually, sometimes a better result. For instance, here is a 1 species template. See, 1 species. We need to change the Z effective and the tau. So those 2 numbers need to be changed. So Z effective, when you have all the species, Z effective will be 1. But once you do like 1 species, you need to change the Z effective. And also you need to add a tau. So how to get those numbers? You can use again from IFS script. If I remember it correctly, it should be called a Z effective C cog ID from Z effective. And of course, that's the old version. So how about this one? And the impurity that I'm having is carbon, so it's 6. So there's the effective. We can zoom in to the point of interest if you want to, and just eyeballing the number, and here's ID that you don't need to care. Here's tau that you can eyeball as well, but for this it has location of interest. For instance, I want to do 0.98, x equals 0.98, and it will give me the Z effective, tau, and ID. You just need to copy those and put it into the parameter file. I already did. And then you can run this. This is how you do the one species. So for one species, see the species only one, you can just delete those two other species. Anyway, so let's look at how the cock effective ID works. It's pretty simple. Basically, read into the profile EIZ that will be generated once you run the make iterdb file. So make sure that profile IEZ are there when you run the cock effect ID. And for submission, it's highly suggested every time you run something, unless you just run something really quick. If you run something very long, say like 10 hours asking for 10 cores, 20 cores, I suggest you to run a debug with 30 minutes and also with the same core and everything to see if your code actually runs. Sometimes you parallel it wrong and you wait for 2 days and then it give you spit out your error. So it just not worth time waiting. So you just submit a debug queue. It will be start running almost immediately, and then see if there's any errors. If there's no error, change to regular and then run it. So I will just change to regular, and you can give however much time you want, say like 10 hours. But see for the demonstration purpose, we'll have running in the debug because it barely need to wait. So we have 30 minutes. That's a maximum time that we can run on debug queue. So we do sbatch and submit that, and then the command file that you read at .command .command. And now submitted, you can write down those numbers so that I can check it for the future. And also if you want to check your stuff, QUEUE, SQUEIU, my username, and it will give me the information of such job that I have. If you want to cancel, you can do scancel, and the number, say 598892, and now it's cancelled. There you go. So that's how to run a local linear simulation from 3 species and 1 species from experimental data.